What do you guys think about the keynote? It's pretty awesome. Yeah, I learned a couple of things there myself. That's pretty amazing. So welcome. I'm really happy to see the amount of testing and quality content that we have for this conference. My name is Karl Krukov. I'm the Xamarin Test Cloud technical lead. And for me, it's just amazing to see so many talks, so many people talking about mobile quality. Because really, mobile quality is extremely important. So, if you do not live up to the expectations of your users, they will stop using your app, they'll uninstall it, and they might go to the app stores and give you a bad rating. And the expectations of users are extremely high. You heard it already from Nat in the keynote. Your app is sitting next to the world's best apps. Apps like Facebook, Google Maps, LinkedIn, Twitter, YouTube. Those are the apps that your users will be comparing your app to. So expectations are really high. At the same time, living up to those expectations is extremely challenging. You heard it in the keynote, I'll repeat it again here, but there are more than 17,000 different configurations of Android out there. So combining the model, the hardware model, with the OS version, all those combinations, 17,000. And OK, even if you didn't want to support 17,000 devices, that's fine. Let's assume that you wanted to support 75%, the top 75% of devices in the US market share. Even if you only wanted to do that, you would still have to test your app on 134 devices. And in fact, this data is slightly dated, and I'm pretty confident that the number is higher now. So this amounts to a lot of work. So this talk will be about mobile quality and the way that Xamarin sees mobile quality. It's a joint talk. I'll be presenting the first part, an introduction to how we see it, state the problem, introduce the tools and services that Xamarin offers to help you solve this problem. The second part will be the fun part. And here we will have our testing frameworks lead, Rasmus Larsen, who's working closely with me on developing the testing tools that Xamarin offers. So he will come up, he will show you a live demo to show you exactly how do I go about using these tools and services. So that should be really fun. And we have a special surprise coming up also for you. I won't tell you what it is. So let's go back to how companies are testing their apps. So recently, Xamarin performed a survey, and it asked the companies that are in the survey, so how important is mobile quality to you? And the results were pretty interesting. So more than 77% answered that mobile quality is very important or mission critical to the business. And then we went to ask them, how do you go about ensuring that quality? And that answer was also interesting. More than 80% of the people who responded said they are relying primarily on manual testing. That's a problem, though, because there are problems with manual testing. It has implications for the development cycle about how productive you can be, how fast you can push out updates, how much coverage you can get for testing. There are several problems. One of my biggest problems with manual testing is that it leads to slow feedback cycle. So we were talking with this one customer that was interested in using Xamarin Test Cloud. And so we asked them, so how are you guys doing testing now? And they told us they had 1,800 use cases written in Word documents. And when they had completed a an iteration where they produced a testing build of their app, they would take this binary and these test cases written in Word documents, and they would ship them to an external testing vendor. And so the testing vendor would use the devices that they had, go through these step-by-step instructions in the testing use cases. And 22 days later, they got the results. 22 days. That is a lot of time. That's a lot of time. That's a lot of development going on from the moment you finish that test build. Well, you keep working. You're still developing new features. Getting information 22 days later about how the state of the application was 22 days ago, it's terrible. So that's my biggest complaint. Also, manual testing is not scalable. what happens if you want to increase the test coverage of your application? Well, the only thing you can do is hire more people. There's only so much work a person can do. So you need to hire more people, or you need to pay more money to these external testing vendors. Manual testing tends to be not so reliable. Humans are prone to error, particularly when we give them, a repetitive, maybe not so interesting task. So the reproducibility of your test results will suffer from this approach. Also, commonly, manual testing will be associated with a low device coverage. And the reason for this is that the people that will be that will be testing the app, they will need all these devices which you will have to go out and procure. So typically what happens is that companies tend to test on maybe 10, 20 devices that they have around. Or if they're very organized and structured, they will have a person responsible for buying these devices, keeping track of where they are, and kind of managing all of that. So maybe they will have, 80, 100 devices. And there's a full-time person managing, who's got them, who's stealing them, do they have SIM cards, all that stuff. Finally, it's also worth noting that the reporting associated with manual testing is usually quite poor and time-consuming. So in the case of this customer I was talking about, they would send these test scripts out to this manual testing. They would get back the results. Well, that was also Word documents that had the test scripts in there, so the test cases in there, and screenshots, printing, and description of the results. Well, the way they would analyze that is that we print those documents, lay them out on the table, look at the screenshots, have their design guys come in, look at them, say, well, there's a problem here on this device. So that would add an additional couple of days of analysis on top of that. So really, that's not the way we think we should be doing things. Our philosophy is a strong focus on automation. So let the manual testers do what humans are good at. We're not trying to replace humans, because humans can do things machines are not very good at. But instead, let's try to remove the boring, repetitive, scripted work from the human labor. Manual testers have experience. They're creative. They have a brain. Let them spend their time using that experience to test cases that are hard to automate, cases that involve a human judging whether the user experience is good or not. That's the way we see manual testing. We will still be doing it. But let's do less, and let's do more interesting things. Focus on automating. So automate your build, automate your testing. Write unit tests, write integration tests, and write UI or acceptance tests. Once you have that, make sure you're constantly integrating the various lines in your source code into your master line. Make sure you're constantly running these automation scripts to build and test your app on that master line. We call that continuous integration. And in fact, there's a talk today by Greg Shackles on how you go about setting up continuous integration for your Xamarin projects. How do you set up testing? How do you combine that and integrate that with several things, including Test Cloud? So I highly recommend that as a sort of how do I get started doing this? We also think, Nat mentioned this in the keynote, that testing is not something you do at the end. Testing is something you bake in from the very beginning of your project. That way, you get the most benefit. And you get good at it. If you insist on doing this from the very beginning, you will get good at it. Finally, and this is also one of the reasons we built Test Cloud the way we did, is that in mobile, it's really important that you test your application in the realistic environment that it will be deployed into, which means the devices of your users. There are certainly benefits to emulators, simulators, but if you want to be sure that your application will function correctly at that end, to build that confidence, run it on real hardware. OK, so that's how we see it. How do I go about doing it? Our answer, as you saw in the keynote, is Xamarin Test Cloud and the tools associated with that. So I'm not going to give you a long description of what that is. You've already seen it in the keynote. You've probably heard about it before. Rasmus will demo it later. Sorry. But I will give you just a short kind of bullet point kind of thing. So first of all, we have more than 1,000 real devices. These devices are not jailbroken. They're just the same devices that your consumers would go out and buy in the stores. We pay very, very close attention and care a lot about the security. So that means that this is a shared environment. It's a cloud environment. However, in between each of the test runs, in between each customer test runs, we go to a great extent to ensure that the devices are fully wiped of your data, to ensure your privacy and secrecy. So that's an important point. It's important also to understand that Xamarin Test Cloud has two key components. So if we dive down a bit, the first is called Xamarin UI Test. So this is what you saw Chris demoing in the keynote. You are able to write tests in C#, run them locally on a connected device or the Android player or another emulator. So that workflow is you're sitting locally, you're writing a test, you're running your tests. Now you built your tests, you're happy. You compile the binaries of your application, and you ship those same tests to Xamarin Test Cloud along with the binary of your application. And I'll go into detail to give you an overview of what exactly happens when you do that. But at the very high level, what happens is that that application will be distributed onto the devices you selected, and the test will run on those devices in parallel. That very same test that you ran locally. OK, so what is Xamarin UI Test? So it's a niche package. It is available from right in the IDE. It allows you to do UI test automation. So on iOS and Android, you will be able to simulate a user interacting with the application. You can tap, swipe, pinch, do various gestures, enter text. But you can also do interesting things like simulating the rotation of a device or simulating the GPS position, something that can be a lot of work if you were testing this manually. As I mentioned, tests are written in C#. They're run with NUnit. And you can run these tests directly from inside the IDE. So if you look at the code snippet, you see this app object. And on that object, you can do various methods that represent what the user would do. If you notice the parameter passed to app, what that's saying is that it expresses find me the element E, which has the ID history button. So we have a small DSL, which gives you a fluent interface for declaratively picking out views. Xamarin Test Cloud supports all apps, independently of whether they were built with Xamarin, the native platform tools like Java and Objective-C, or even hybrid apps. So remember that hybrid apps are native apps, but they contain web views. And inside of that web views, you have a DOM tree, and that you can interact with that DOM tree using CSS selectors and the regular methods like tab. So that's being used by a lot of apps, particularly enterprise apps, and it's a really useful capability to be able to interact with that. I mentioned already, run on device locally, run on simulator. So to understand how a UI test will run, we need to just understand the basics of its architecture. So it's a networked architecture. You have your host machine, which is your Visual Studio machine or your Mac. And in there, you author your test. And when the test executes, it actually executes on the host machine. It doesn't execute on the device. So the test itself, the testing code, will run on your machine. Then we install on your device, next to your application, something we call the Test Cloud agent. And the Test Cloud agent is a privileged component that is able to perform the automation on your app. And it can also do advanced things like reflect over the objects of your app. So you can actually go into your app, look at the state of objects, call methods on them. And the way those two are connected is using a simple HTTP-based protocol. So the test script, when we say tap this element, actually sends a command to the Test Cloud agent, which goes about it and does it. So it will perform a method or synthesize a touch gesture using the platform automation tools, which are already in the platform. It will collect back the result and put it back into the testing script. So this has a number of advantages, having this separation. One being that because your test script is running on your machine, you are not running in a sandboxed environment. So this test can do anything. It's just a C# program. It could talk to your backend services. It could talk to your web services, query the state of your data. It could write files to the disk. It could talk to a database. It's not running in a sandbox, and therefore it's not it's not impacting the performance of the device. It's not running on the device, which other tools do. Okay, so it's network architecture. So what can it do? I mentioned already you can interact with UI controls using gestures. We have this query language, which kind of gives you a declarative way of talking about elements, talking about UI elements. For instance, you can talk about them by ID. You could also talk about them or identify them via their position in the view hierarchy. So it's the sibling of the object that has this ID, or it's the parent of the object with this ID. It's a very expressive language, high-level language. It's not based on coordinates, so if you move the UI around, you restructure it, well, your test is most likely going to still work. That's really important for robustness. Okay, so to do the testing, you need to do other things. You need to be able to wait for certain events to occur. You don't want to sprinkle your test script with sleep 5 seconds and assume that after 5 seconds, the server will have responded with some data. That's going to be a fragile test script and slow. So you can wait for events. You can generate screenshots, which is used extensively in Test Cloud. And there are some app lifecycle APIs for launching apps and installing apps and so on. The infrastructure you need to do this automation. The final thing I want to point out is that there are also some low-level APIs that will let you do things that even the user could not do, which is sometimes really handy for automation. You can use it for various things, for instance, speeding up your tests by setting the application to a certain state before you run the test. So what this API can do is that you can find an object in the view, and then you can reflectively call any method on it. Commonly, it's used to extract data from a view. So let's say you're showing a list of labels. Give me the string text of all those labels. But you could even call setters if you wanted. That's not a typical testing thing to change the application that it's running, but the power is there. Okay, so 2 components. What I talked about now is kind of the local component. What can I do? How do I write my tests? Now let's look at how it will execute when you submit it to Test Cloud. So we assume you've written your test, you've compiled it, you have your application binary. Now you want to run it on Test Cloud. So you go to the website, or maybe you've gone to the website before, and you have this key that identifies which devices am I going to run on. So we have that. You will upload to Test Cloud. You saw it in the keynote that it was a right-click Visual Studio run on Test Cloud. That's one option. The other option is a command line-based tool, which you can integrate in your CI systems to ship the testing code and the app to Test Cloud itself. That's received by Test Cloud and is kind of asynchronously transferred to a scheduler component. Because what's important is that since we have all these devices and all these customers wanting to run tests on them, it's important that at any given time, only one test is running on a device. Otherwise, it'd be pretty terrible. So there is an exclusive access to the device. And the way we do that is using a queuing system. But in fact, it is more sophisticated than that. So it's not just a queue. The scheduling component will do more. It will make sure that we actually have the server capacity to execute the test that you want to run. It will make sure that if a high priority test has been submitted later than a low priority test, it will shuffle around the priorities. So there is an advanced logic and scheduling going on there. But let's assume that a device is now free and we can start running. Then the next step is that the app and the test scripts are shipped to what we call the executors. And these are servers that will actually run your tests. That's the basic job of them. But something else happens before that. Because now we pick the device, we want to run on it. But to make sure that when you run the test, you're running on a reliable device, we do a very extensive test up front that will make sure that the device I'm just about to run on, is it connected to Wi-Fi? Does it have a decent quality of service on the Wi-Fi? Can it install apps? Is it ready to go? Is it completely wiped of customer data? A sanity check that all that is going on. That's a very extensive test. And the reason we do that is because we want to make sure that once your test runs, it can depend on the device. In fact, if this sanity check fails, the process will stop. and it will go back to the scheduler to schedule that same test on an equivalent device. So we have multiple copies of each device configuration. So that way, kind of transparently, you avoid some random device acting out. But I can tell you that running a device lab of 1,000 devices, some are high-end, some are low-end, is a challenging task. They do act up. They do run out of battery. But you should not be exposed to that. That's one of the reasons you don't want to try to build this stuff yourself, is that it is really an extensive task to go. OK, so let's assume that now the device is ready to go. Your test will execute as they did locally. But as that execution is happening, we're collecting performance data. So we are collecting the CPU usage, the memory usage of your application as it's executing. We're generating the screenshots, the video recording you saw in the keynote. We're analyzing for application crashes. In case there's a crash, on iOS, if you provided a dsym file, we will symbolicate the crash for you. So you get all of that extra data ready for you to see in the test reports. So we do this execution in parallel on each different device. We gather the data that is processed, and in the end, you can go to the Xamarin Test Cloud website and view this test report with all the devices, the screenshots, the data. Of course, if you're running from a CI system, you also want this to be showing up in your CI system, and we do that also. So you can see, you can get a pass-fail and some information about the test from inside your CI system also. It's built for CI from the beginning. OK, so I hope that gives you a great overview from the high level of what Xamarin Test Cloud is and what Xamarin UI Test is. So now I'd like to give Rasmus a warm welcome, and he will give you guys a demo. Hey.
Hey.
He will give you guys a demo of what this looks like in practice. So please go ahead, Rasmus.
Hey, guys. OK, so I hope you're excited. I think we've had enough slides, so let's just jump right into the demos. Let's just put this away. OK, so what we're going to be talking about today is I'm going to run you through building a test scenario in the Xamarin UI Test. And what I have my setup here is that I have a physical device connected. I'm projecting it onto the screen here with Mobizen. And we are going to be testing an app called Mobile CRM. And Mobile CRM is actually one of the pre-built apps that Xamarin has. So you can go and fetch this app and look how it's built, if you want to. So let's take a quick look at the app first. And here we go. It's a Xamarin Forms app. And the flow that we're going to be automating is that we're going to go from this dashboard. We're going to go into the accounts page. We're going to take one of these pre-existing accounts. We are going to go to their orders page. And we're going to create a new order. In here, we are going to pick a different product. And we are going to enter a price. And then we're going to place the order. And then to complete this cycle, we are going to open one of these existing orders and then enter the final price. And then this app also uses the Xamarin component that's the signature pad, that you can use to write signatures for stuff. It's pretty hard to do with a mouse. I think you get the idea. Let's just take the last one. There we go. And then we're going to complete the order. Right, so that's the scenario we're going to go through. And I'm going to take it from scratch, and we're just going to build it out in Visual Studio. And then after that, we're also going to take a look at iOS testing. And yeah, so let's get started. So here I have my solution with my Android project. And I'm just going to add a new project to it. Here we go. So it's really basic. So we're just going to grab a class library for this. Migrate evolve tests. I think that should be fine. Let's get rid of the infamous class 1. I don't know how many of those exist, actually. And we are going to go and grab a NuGet package. I don't think we need the other joke anymore. So we're going to go and include NUnit. Yep. and Xamarin UI Test. Here we go. And once we have those installed, we can start writing tests. And these tests will just be basic NUnit tests, so they can be run in any runner, like the Test Explorer or ReSharper's test runner that I will be using. So let's create a new class, my first app tests. We're going to mark this as an in-unit test fixture. There we go. And then we are going to create a setup method. And what this does in NUnit is that it'll run before all our tests, before each one. And we'll be using this to tell UITest to set up our app. So I've prepared a little snippet for that. We're going to include UITest. What we can see here is that we're just calling the static class configure app. We're telling it we want to test an Android app. We're giving it the location of the APK file that we want to be testing. And then we're telling it to start the app. And once we reach this start app method, we're going to go UITest is going to run out. It's going to find the APK, make sure that we have this Xamarin Test agent running on the device, and install everything and make sure the app is launched. So if we just, oh wait, I didn't want to. Let's just pull this out into a field instead. Whoa. There we go. OK, so we'll have this available in our tests. So if we add a new test, and maybe we should call this what we're going to do. So we're going to place an order and complete one. Complete one, yeah. Right. So if we just run this empty test, we can see the app launching. So now we need to start automating. And I know that what we wanted to do here was to get this, this menu out. So what we're going to do first, that's pretty easy. We're just going to do a basic gesture. And this app instance, as Chris also mentioned in the keynote, has all the options that you have to interact with the app. So this is the gateway. You don't need to know anything else. As soon as you have this instance, you have everything you need. So if we just swipe right, it should open the menu. So let's just start running this test again. And as you might notice, these apps always have some kind of overhead when they start up. They are always loading data. This one is showing a white screen for some reason. And then we can see now the test is actually executing, and we're opening the menu. But if I continue to add stuff here at the bottom of my test, it's going to take a while, because each time I add a new step, I'm going to have to rerun the entire test, and I'm going to have to wait for the device to be automated. So we're going to be using the REPL that Chris was also showing off in the keynote. And that should hopefully speed things up a bit. So just to reiterate what Chris said, the REPL is just, you can think of it kind of like a mix between a breakpoint, because it's going to stop the execution of the test at the point where you are calling the method, and the interactive window in C# where you can actually, or in Visual Studio, where you can actually write C# so you can do evaluating simple expressions. And the main thing that we use this for, obviously, is to interact with the app. So we're here, and we have the app open, and we want to interact with we want to press the Accounts button. This should be fairly easy, because we can see the text, and we can see that it's here. We can see that it has the text account. So we're just going to tap it. So we're going to select something, and this is the query language that Carl mentioned, that is basically a Fluent API. So we can chain these together and be specific about exactly what we want to match. And we're going to be seeing different kinds of queries that we can do throughout this demo. So if we tap the accounts page, it should go to the next page. Great. So we want to select the first. We just want to select the Bay Unified School District. So if we look at the UI tree here, we can see that it doesn't really have any interesting IDs or anything. So the only thing we can do here is really select it by text. But we don't want to write all that out, so I'll take the opportunity to show you another feature. So we can also do predicates for our queries. So we can go in, and Carl mentioned this quickly, that we have the ability to call reflectively onto the view elements. So what we're actually going to do here is we're going to go and say we want to find all the elements that have the text containing bay. So the test server on the device will actually go and call this method on all the matched elements, and it will only return the ones that match this predicate. Yes. Then we want to go to the orders page. I think we'll just tap on the text. Should be fine. And then we want to create a new order. So if we look at the UI tree here again, we can see, here it is. We can see that it's a button, and it has the text new order. So UI test also includes, the query language also includes common controls. So we can say button, and this will match the various platform buttons. So on Android, it would match an Android widget button, and on iOS, it would match a UI button. And we can also, for instance, if there are multiple buttons, we can also query and fetch the information about these. So if we try and do a quick query for button, we can see here that the query method is a way to extract information about the view elements. So as soon as we run a query, we will be presented with this general information about the component or the element. We'll get the ID, the description, where it's located on the screen, how big it is, and then the text and the underlying class that it has. So what we want to do now is we just want to tap the button. And let's be a bit more specific. So let's just say the one with the text or ID new order. Right. So here we want to select the product. And we'll just do this again. Here we go. So you can see here that the title of the bar is up here with the product. And then we have an edit text with the text paper. And it's a picker renderer that's doing this. So to activate the control, we're just going to tap on this picker renderer. We don't really have a good ID or anything, but we can also match elements by class. That should open up the menu. We can take a look here. And there's not really much useful information about the elements here. So we're going to use the same mechanism as before, reflectively calling on the view elements to automate it. But this time, we're not going to be fetching information. This time, we're going to be telling the UI or telling the view element what we want to happen. So we're going to be using the query method, and we're going to be looking for this number picker. So we're going to match class number picker here. And then we're going to do an invoke. So the invoke will go and call a method on it. So the method we want to call on this number picker is called setValue. We'll just set it to the index 2. And then we should see it switching to printer. And we can also see that we got the results back. And in this case, it was a void method, so we didn't get anything useful. Then we just want to complete this dialog. So we'll tap the OK button. Obviously, you don't want to be the text selector is very easy to use, but obviously it's better to use IDs, especially if you're translating your app into multiple languages. So we're tapping the OK button. Then we want to enter the price, see if we have any cool information to go. And we can see we have this entry edit text. We don't really have anything useful. We don't even have a text in it. So, but we can use one of the we can actually just query, and then we can ask UITest to find all the text fields. This is another example of stuff that will, or a selector that will find cross-platform things. So we'll do the right selector for the appropriate platform. And if we do this, we can see that we have 1, 2, 3, or 1, 2, 3. Yeah, 1, 2, 3. And since we don't really have any good information to go on, we're just going to be using an index. So we're going to be telling UITest, OK, I want you to press the second text field. If we're unsure where these elements are, we can also ask UITest to actually highlight them. And now you should be closely looking at this over here, because they will be highlighted in a second. And it's a bit fast, so it makes sense when you're sitting at your computer, but it's a bit hard to see if you don't know what you're looking for. So we were going to be highlighting the text fields. So now we can actually count 1, 2, 3. So we're going to be entering text into the second one. There we go. And then this is 0 indexed, obviously. So we will be doing the first one, and we will enter the price 100 like we did before. And then we just need to hide the keyboard. We can see on this device, on this particular device, we can see the place order button. But on other devices that have smaller screens, it might not be possible. So it's always nice to just hide the keyboard before we're continuing our interactions. And now on this screen, we can see that there's a place order button and we are going to tap that. So let's just click the button. Right. So now we want to actually go and complete one of these orders. So we are just going to take the first one. If we go up in our UI tree here, we can see they don't really have anything interesting. So we're just going to match the text printer. That should get us into the first one. And you can also see here that UITest is actually writing out that it's tapping the first element out of 7, matching our query. And this output will also be available in the output window from your test. So when you're looking at, when you're trying to debug a test, you can see what UITest did. So now we're on the final screen that we're going to automate. We want to enter a final price, and we want to draw this signature. So if we start with the final price, we are going to use enter text again. As far as I remember, it doesn't have anything really interesting, but we will use the text field method again. So we'll say enter text, text field, and this should be the 0th one. So we'll just enter 1,000 here. Should work. We'll hide the keyboard by clicking the back button. And now we're at the state where we want to draw the signature. And even though I could do it from the REPL, I have a bit of code prepared to do that because it involves coordinates and stuff. So let's just take the stuff that we've done so far and bring that back. And we have this copy command that will take the entire history that everything that we went through in the REPL, put it into our clipboard, and then we can bring it into our test so we can use it for. So we'll just paste it in here. You don't need 2 + 2. You don't need the REPL. Right, so is there anything we should remove here? Flash? OK, let's do that. Should we see if it runs? Now, there's a lot of animation and stuff in this app, so this might not work, because it might be needed. We might need to wait for certain stuff to happen. So, but let's try and run it and see what happens. Seems to be going OK. Great. So what's going on here is actually that when we do these gestures, UITest, this is not just a tap. Because UITest will go and ask the system, hey, I need a view element that has the text accounts. And the app will say, hey, well, I'm loading. I don't have that element. So UITest has 2 options. It could either throw an exception, or it could wait a bit and see if it comes up. So it will actually wait for and keep querying the system asking, hey, do you have it now? And if it times out, it'll throw the exception and say, hey, something that you expected to be on the screen is not there. So that's why this works when we go through it like this. And so let's add the signature part. So I prepared a small snippet here that we'll use. So OK, so let's go through this. So I didn't show you in the tree before, but this signature pad has the class signature canvas view. So we're going to do a query into the system, get out the general information about the element, and we will calculate an offset because we want to draw something. And we will take the center coordinates, and then we will use drag coordinates. So we will actually ask UITest to drag across the screen. And now, obviously, we have to run the entire test again to see that, but let's just do that real quick. Getting there. Oh, yes. Works. Right. So let's take a look at. So that was actually the scenario that we wanted to automate for this demo. So let's just actually the last thing we want to do is to have this button down here at the end. But I think I can do that without the REPL. And let's not run it. I think you've seen it. So let's go and take a look at iOS development. So at the moment, writing iOS tests is done in, well, this is small. OK, we're not going to be looking at the code for that long. But iOS tests need to run on OS X at the moment. So we are doing it in Xamarin Studio. And this is basically the same scenario that I just showed you. The only thing that's added is calls to this screenshot method. And this screenshot method is used in Test Cloud to create the steps that you saw earlier in the keynote, and which you will also see when we go to Test Cloud in a moment. So let's just try and run this. For iOS, in this test, we're running an app bundle, which means it will run on a simulator. You can also run on a physical device, obviously. That's a big iPhone. Whoa, that's a huge iPhone. That's a better iPhone. So as I mentioned, this is a Xamarin Forms app. So this is just the iOS UI. There we go. Great. So when we want to, what we would like to do is share some of this code between iOS and Android. And the way we can do it is to try and get the test scripts, or extend our language so that our test scripts can deal with the differences that we have on the different platforms. So as you might notice, this our draw method here, it's a different abstraction level than the rest of it. This is talking about something we want to do. We want to tap on the app. This is something like we want to fetch some information. We want to do some calculations. We want to do something coordinate-based. It's not query-based. It's a different level of abstraction. So we would like to, maybe we're in the industry of drawing X's all over the place, and we just want to extend the language to support this. So we are going to extend it with a static class here. My extensions. Oh. There we go. And then the first thing we're going to extract is this drawX method. So we are going to create an extension method. It's called drawX. And it's going to extend Android app. So we should be able to grab all our code up here. Basically just paste it in here. Seems to work. And then obviously we can go, since it's an extension method, we can go draw X up here. So the next thing that we want to do is we wanted to be able to use this from iOS as well. So the first problem is that Android app is not iOS app. But both Android and iOS app, they implement an interface called iApp that we can use. It contains all the shared stuff that we have between iOS and Android. That's almost everything. So you can see here all the gestures that we can do on both Android and iOS. So maybe we don't just want to, so this is how you can extend the vocabulary of the gestures that you can do on the app. But maybe you also want to extend the query language itself. So at the moment, this draw X method will always draw X's on the first signature canvas view it can find. So let's try and take this out. So we want to give this draw X method support for doing queries on other things. So you can see up here, now we have draw X and then our query. So we could go in here and we could do button instead or something else if we wanted to. But we can actually also, the problem with this query here, we have the class signature canvas view. But if we go to the iOS test, and maybe this is a bit hard to read, but it's actually called signature pad view on iOS. So we would like to be able to extend the query language as well. And we can also do this by adding, oh, we need to return app query here. And then we will extend the query with the method signature pad. And it's really simple to write an extension. We just need to return the query again, and then we need to chain on whatever we want to match. So in this case, we wanted to match the signature canvas view. Right? So now we can actually, and this is useful when you have, because you guys, you know your app domain a lot better than I do. When we're building UI test, you guys have special components you want to match. So this will help you extend the query language and not having to write the same query over and over again. And when you change your app, then you need to find it in a different way. So you can extend it here. And the other thing is actually that we can take this back, and if we try and open the REPL again, so when the REPL launches, it'll actually go and look at your assemblies, and it'll look for extension methods that are extending UI test, and it'll load them. So you can actually, we can do draw X here. So now we have this available in our general language. And maybe if we wanted to draw on a signature pad, not a signature, so like this, we will get an error message because there's no signature pad on this page. But we can draw on other things as well. Now I know that this button up here has the ID up. So let's try and draw an X on that one. So we're drawing an X, and apparently that means to slide the menu out and in again. And that makes sense because it's 2-click events. Right. So one thing I didn't mention down here is that we wanted the signature pad query method to be cross-platform. So if we check on query platform, we can actually go in here and say, is this app or is this test currently running an Android app? Otherwise, we can return the class name for, what was it, the signature pad view? Yeah. So now we have a method that we can reuse. Right. So let's take a look at this running in Test Cloud. Test will keep running over here. Right. OK, so we have 2 instances of the app uploaded here. We have the Android one. That's the one with the, or the iOS one is the one with the round corners. Makes sense. Right, so I have some test runs here. We can see they've failed. I've run a similar scenario to the one that we just saw. We can see the overview page that you saw in the keynote has the information. We can see that we failed on one device running Android 4.1.2. And if we go into the app, we can see, you can see over here is the same set of, maybe I can make this a bit bigger. Apparently not. OK, so you can see the steps over here that we ran through, and if we use the arrow keys, we can go down and see what it looks like on all the different devices. So if we want to see what the failure actually was, it failed down here in draw signature, and here's the device that failed. So the failure was because we weren't able to see, we couldn't see the signature pad, so it wasn't visible on the screen. Or we can only see the edge of it. And it turns out that when I was writing these tests, I was actually, OK, so we need to scroll down on this page to find it. But it turns out this view is actually not scrollable. So this would be a problem for end users. They wouldn't be able to complete this form. We actually see the same issue if we go into the iOS one. We can see here that the iPhone 4S, this is actually even worse because we can see the signature pad, but we have no notion of a complete order button down here. And from the looks of this view, it's not even obvious that there should be anything below this. Right. So, and when you create a new app and you want to run your test on Test Cloud, you go into this new test run thing or flow. And then you select the app. And then you get to this device selection, where you can see all the different devices that we have in our different labs. Yes, Carl?
I don't think these guys actually believe this is real. This is just a website, right?
It has pretty pictures.
Would you guys like to see what that looks like for real? Yeah?
All right.
Why don't we do that?
Well, as it happens, I actually have an app we can test.
Oh, good.
So, all right. So I think we're going to try and just start up Xamarin Android Player here.
That was fast.
Open. Yeah, it was. Amazing. So if we just go here, I have two components here. Let's close down this simulator. Right. So I have created a very, very ugly app here. And it's basically just a soundboard. It can do two things. It can report.
Reporting.
And it can play a song. And that's Jonathan Couton's Code Monkey song. And as you can see, I actually dropped the Xamarin component for Signal R integration into this app as well. So I have a web UI over here where I can actually remote control this app. So if I click over here,
reporting.
I'm remote controlling this app. You can also see that there's one device connected at the moment. It's this one. And let's just try and hear a small bit of the song, just so you know what it sounds like.
Code monkey, get up, get coffee. Code monkey, go to job. Code monkey, have boring meeting. Boring manager Rob. Rob say code monkey very diligent, but his output stink. His
right.
Not function.
Right. I think that does it. And we can also control the volume, and we can kill the app. There we go. Right. So let's try and run that in the cloud. So I'm just going to go over here. I created a small script for uploading. This is the same script, a similar script that you would use if you're using this in a CI system. It's just a single line of command line. So we're uploading to the cloud. Let's just do 2 uploads. Right.
Yeah, so you remember I was talking about the process for uploading with Test Cloud. You build your test, you have your application binary, it's shipped to Test Cloud, and it's asynchronously scheduled. So the process that's going on now is that we have the scheduling going on. So we hope there's not a lot of queuing going on at the moment, because we will need to wait a bit. We got 20 minutes, so don't worry. I'm expecting a faster turnaround. And then you remember this, this initial create session, which will do the sanity check of the devices. So it'll take a few minutes. So as we're doing that, we're making a call.
Calling Vilas, our procurement manager. Hopefully he will be there.
He should be working. What is in Denmark?
Doesn't seem like he's there, though. That's a bit unfortunate.
Seconds.
Wait, maybe we should take a few questions, and then we can try again.
We'll try again. He should be there, so maybe it's a connection issue. But you see these tests are starting to run. We'll try calling him again. We can take a few questions while this is happening, but we do have a final demo we want to do. I know you had a question. Yeah. Sorry, I just want to mic you up. OK, you can speak loud, and I'll repeat the question. What happens if the application crashes while the test is running? Yeah, so let's say you have a test suite with several tests, and as you're going through one of these tests, the application crashes. Now, Test Cloud will detect that crash and analyze the stack trace and so on, so you get that. But at that point, it doesn't make sense to complete the rest of the test, because the app's not in that state. However, the next test will launch the app again and run the next test script. So it will, like, say, this test failed. We keep running the rest.
Oh, wait, we're live with Vilas now.
We will do more questions, I promise. We got the connection. So this is in Denmark. Hi, Vilas.
Oh, and the test is actually already running, and it's when the test activates a device, it will say reporting. And then we can also remote control it from here. And you can actually see it running on the devices in the cloud.
Can we get some sound?
You can hear that there's an occasional reporting from a new phone that comes online. But we can actually also make all of them say reporting at the same time.
How many devices, Rasmus?
We're at 90 now.
Say it again. This is happening live, real time in Denmark.
So, I don't know. Should we wait for 100 devices before we play the song?
Maybe just a few more. Can turn the sound down a bit.
I killed some of them before because I thought that we were going to be retrying the whole thing. But maybe let's just try the song. And do know that this might not sound very good because it's being broadcast live from Denmark. So
live via FaceTime.
So what does oh, we're 97 now. 97. Is there any more coming? Yeah.
Oh no.
No.
Reconnecting.
Maybe I shouldn't. Maybe it's when I swap.
Yeah. Let's hope he reconnects.
When it reconnects, I promise we'll play the song. You are answering the question.
Yes. We want to hit the play button.
We reached 100 devices now.
You had another question, yeah. Go ahead. No, let him ask his question. That's OK.
I see on the Test Cloud, it keeps the crash. But what happens if I'm just running locally, not on the Test Cloud?
This demo?
No, just on the device, in emulator, not on the Test Cloud.
Locally, you can run it on device, on emulator, on simulator.
Oh, OK. Thank you.
Go internet.
Go internet. I don't know if it's probably his internet though, because ours seem fine.
Yay!
Oh, there he is. So let's. I think we should do the song now.
Gotta hurry up.
Otherwise, and we're actually way across the 100 devices now.
Yeah.
Now we're 132. So let's just do a reporting again, just to see. And let's try and play the song. So that's 140 phones playing at the same time.
Yeah, thanks for turning the volume down.
Yeah.
All right, that's it for the demo. Thank you, Rasmus. Thank you, Vilas. We'll go on to take questions. I'm sure there's a few questions. We got about 15 minutes left. Before we do that, I want to just point out one thing.
Have a nice evening.
See ya. I just want to point out one thing. We have another talk today. I already mentioned Greg Shackles, who's talking about CI, how you set it up. I also want to point you to Nils from eBay Denmark. He will talk about how they've managed to integrate this into the development and testing process now for, I guess, a couple of years, and the kinds of improvements they've seen from this. So I really recommend that as an experience report on what taking a good approach to testing can do for you. All right, thanks, Rasmus. And we can go on with questions.
Okay. I'll ask Gwen first because I got the mic over here. What's up?
Yeah, hi.
Let's say I want to test environment variables like connectivity or location accuracy. Is there any control over that so I can?
Yeah, so I mentioned already the ability to simulate the GPS location. There are other things that are harder to simulate. The network connectivity you're asking, it's not there at the moment, but it's actually on our roadmap. So being able to test the offline scenario, which we can actually do in certain cases already, but more fine-grained control of the connectivity properties, that's definitely on roadmap, yeah.
Along the same lines, VPN client capabilities?
I'm trying to, can you repeat, sorry?
The ability to use a VPN client at the same time.
Yeah, to connect to your back-end systems. The way we do it at the moment is that we open up, we have a fixed set of IP addresses, and we open up client firewalls to access those back-end services, or we go against the production environment. More sophisticated ways to do that will be needed for certain types of customers. Definitely something we're looking at. Yep.
Do you have ways of testing things like backgrounding and then coming back, or anything like that?
Yeah, you can do backgrounding, coming back. There's a built-in, on iOS it's called send app to background for duration. So you say, I want to put it to background and wait, and then it comes back.
Hello?
Yep, hi.
Seeing the video that you have shown, suppose if we are working on speech applications, okay, you play a song, it's good. It's speaking, it's good. But how do you simulate a user speaking to the phone?
Yeah, so this is nice. I like these questions because people get excited. I want to do testing. I want to do this. I want to do that. Clearly, not everything can be automated. If we were to put in sound projection, which is what you're asking for, onto the devices, that would probably not be stable because you have an environment of the lab you saw here had about 600 devices. If one device is playing a song, the other is trying to project a sound onto for a voice recognition. And that's not going to be a stable environment. So that kind of scenario is not supported. There will still be things you will be testing manually. That's kind of my intro to the talk is, let's try to automate what we can, make the challenging things manual tests. But there are sometimes we want to push automation further. So what people sometimes do is that they mock out the external dependencies and provide that input, say, with a file or something. So there are sometimes you can, if you say, okay, I want to dedicate myself to automating this scenario. Sometimes you can, mock things out, mock external dependencies out, and you could get a pretty good confidence in your app functioning, even though you're not actually testing the iPhone microphone. This one here.
Yeah, hi. You showed some ideas on how to organize your code when in cross-platform scenarios. Can you elaborate a little bit on how you're supposed to do that further? Like, for example, in your setup method, you have a hard code to which app you want to load.
Yeah.
But how should you structure your projects and the code to support cross-platform UI testing?
Yes. So cross-platform UI testing is definitely supported. You saw Rasmus mentioning it a couple of times that the queries actually map to different things on platforms. Because in the end, the platforms are different. And sometimes even your UIs are different. So I would never expect a complete code reuse without having to take platform differences into account. That's the first thing. Now, the second thing you can do is you can organize your project in such a way that you have a shared test file that's a part of both of the Android and iOS test projects. And then you phrase that test using an abstraction that's common across both platforms. Then you push down the platform dependencies into specific classes. This is sometimes called the page object pattern or the page object model, which will let you reuse the logic across platforms. So that's definitely the architectural approach you would take to that.
We saw in the test cases that you had that they passed or failed based on whether all the steps executed. I'm just wondering if you can set it up so that you can determine whether the test passed or failed based on if an element is present or based on whether or not the screen says, certain text and so forth.
Yeah, we didn't actually see the assertion part and the waiting. Rasmus mentioned that if you try to tap something and it's not there, it will fail. But there are equivalent functions that do that, except they don't do the tap part. So you can say, wait for this text, this element, to be on the screen, but wait no more than 30 seconds.
Yeah, and
you want to limit to that.
And you can do a lot more because it's just NUnit test. So you can use any assert. You can use the query method that I showed to say, OK, is this method available? Or I want to invoke this method on this element and pull out this value. And then I want to do a completely normal NUnit assert. So anything that will throw an exception will make the test fail. So you can write any C# code that throws an exception, and that will work.
I just realized I forgot to answer part of your question. You were asking about hard-coded path. That's just for the demo. You can pass that in as a parameter. Yeah.
So our app has a different behavior on first run versus subsequent runs. Yeah. Is there any way to do, actually kill the app, not just background it, and then reload the app?
Yeah, that's the default behavior. So the default behavior is that each separate test will stop and start the application, or start the application, stop it.
Actually, can you do it within one test because we've ran in Test Cloud, and basically all of our tests aren't, at least different runs on different devices aren't guaranteed to be a second run. So can you have one run that actually runs the app twice?
I think I'll let you answer there was the advanced lifecycle APIs in the C#.
We're working on building a lifecycle API. At the moment, you're starting the app, and that will handle the installation. Okay. But we're definitely working on it. We've had multiple requests for it. So
yeah, it should be one of the
it's coming soon.
Next features. It's a fine. I mean, you already have the control, but it's a fine-grained level of control you're asking for.
I mean, you could start the app twice. So I don't know.
So if we have older applications that are just traditional iOS, or a client isn't up for Xamarin, can we leverage Xamarin Test Cloud for those sorts of applications as well, or does it have to be Xamarin applications?
Yeah, so Xamarin Test Cloud is independent of the Xamarin platform. So you can test any app, whether you build it in Objective-C, Java, whether it's a hybrid app. You can also use Xamarin UI Test with any app, whether or not it's built in Xamarin. Yes.
OK.
There's a couple of people in the back also that you might be missing. Cool. Yeah, go ahead.
So sometimes when you're connecting to external systems, you might have a login name and a user password. And when you do that, the data is all connected to that user and the password, right? So if you saw on the order screen, there was lots of different orders, and you end up with potentially, if that's centralized, a lot of garbage data. do you have recommendations on how to do this in a cloud environment where you're trying to get access to the one thing that you had just entered, for example, and then mess with that, but you don't want the other contamination from all the other tests all contaminating the same data and trying to manage those problems and headaches?
Yeah, it's a situation that comes up very often, this thing you're asking, that you kind of want to do the same test, but you don't want the tests interacting. So 2 ways to get around it. One is to run them serially, just ensure exclusive access. The other is that we provide some kind of helper methods or environment variables that will help you make sure that each individual device as it's running will log in using a different account. So if you do that and you manage your data on the back end, you will be able to do this sort of testing in parallel.
I just had a quick question about the locally run scenario, so using Xamarin UI Test with your own devices and simulators. Is there any limitation on how many tests you can run or the duration you can execute those tests or anything like that?
Yeah, it's at the moment, we're looking at exactly how to do this, but at the moment, there's 3 ways of running. There is a restricted version, which is the one you just get off of NuGet, that will run on the simulator. And then if you're a Test Cloud customer, you get the full access, unrestricted, you can run any device. And then there's the Test Cloud version where you're running there. Yeah, go ahead.
Hi, yes. Can you, with this, can you query the content, say, of an SQLite database to check that the data that you've, so for example, you've downloaded it, you're storing the data locally in an SQL database. Can you query that from this to check that the data's okay and put,
that's a good question. So you have a database on device, right? Yes. Yeah. So that's not something a user could do if he were to interact with the application through the UI. But actually, it was one of the things I was mentioning in the beginning, that UI testing is great, but sometimes it's really useful to be able to go behind the UI, do something technical. And one way to do it is what Rasmus showed you, using the invoke method, by which you can call methods on view objects. But what you're asking here is slightly different, because you don't care about the UI at all. You want to get at something running on that device that's not the UI. And for that, we have a feature which we call backdoor, because it goes behind the UI. And with that, basically, you can do anything you want. The way that works is that you put in special hooks in your test build only, not in your distribution build. And the test script will invoke those methods and get the results back. So basically, you can do anything. It's extensible. We call that backdoor. And that's being used. You will hear it also in Niels' talk, Niels from eBay, and that they've used this functionality to reduce the number of logins the tests are doing, and thereby increasing the speed, but still having good confidence that the app is working. So yeah, good question.
Yeah, hi. I saw the REPL that you showed. That's great. But in the future, do you see maybe a recording mode?
Yes.
OK. Thanks.
Don't want to reveal too much.
Hi, just a quick question. You demonstrated drawing the signature with the drag coordinates. Is there support for custom gestures, so something like a 2-finger pan in a certain direction?
Yeah, that is supported. The different platforms have different capabilities. On Android, we have complete multi-finger, whatever you want gesture, multi-direction, multi-endpoint. On iOS, there is it's very powerful, but there is not fully arbitrary gesture support. So you can't draw like a 5-finger, I'm rotating it as I'm moving up like this. But I think for most applications, it's very sufficient.
Thank you.
We have a slightly different UI for our Android phones and Android tablets, for example, because we just don't have the real estate. Is it recommended to do things like if statements in the tests, or to just make different test suites that are targeted to the different devices?
Yeah, it's a common scenario and a good question. How do I test my Android phone and my Android tablet app, which are the same app. They're doing the same thing, but they have different UIs. And in fact, the way we view this is that that's just cross-platform testing. There's, in some sense, there's no difference between Android phone, Android tablet, and Android phone and iOS phone. Because they're the same application, they happen to have different UIs. So we recommend the same approach. Structure your tests where you abstract the test logic from the details of the platform using the page object pattern. And whether it's iPhone, Android phone, or Android phone, Android tablet, doesn't really matter. You will still have the same test logic reused. Yep.
Yeah. Hi there. I think you've right at the front here.
I was looking at you. You did not have that voice. I think we can do one more question because we're out of time.
Yeah, this is just a general question really about how and where you see this going in terms of scale.
Yeah.
So there's a lot of people here seem like they're really interested in it, and at what point do you think or how do you see it going forward in the future?
Yeah. So if we are not now, then we will be the largest test cloud in the world. We've gotten really, really good at scaling this. This is why Nat was it Nat that was talking about the curve of devices added to Test Cloud, and he kind of got scared about that because we were going too fast. So we've gotten really good at this. So we can add, our average is adding 100 devices per month, and we can go faster if we need to. So that's the answer. We still want to test on devices. We're going to scale. Yeah, I think that's probably the best answer right now.
And the last question, please, over there.
Yeah.
Yeah.
Hi.
Hi.
This is me. So, do you have plans for private cloud for enterprises if they want to? I'm not sure if it's present now or in future.
Yeah. So there are really, in my opinion, there are three models. There is the public cloud, which means that it's what you've seen. The devices are shared across customers. Then there are private clouds or private dedicated devices, which is the same model. It's a hosted service. You use the same website. But you do get devices that no one else is running.
Right.
I call that the private cloud.
Okay, and that's available today?
And then there's the third option, which is the on-premise solution, where nothing can ever leave your premise. So the server's running, the website's running locally, the storage is local, the devices are whatever you choose to plug in. And the way we do it now is we have the public cloud. We do offer a dedicated device solution where you can allocate devices only for you. We've not yet gone into the on-premise solution, but it's something we'll be taking feedback from customers about.
Okay, thank you.
All right, well, thanks a lot for coming, and I'm ready, and Rasmus is ready to talk to you guys if you want to talk with us. And the Test Cloud team is also here in the front row. Thanks.